Hey everyone, today we're going to explore one of the most popular and powerful machine learning algorithms, random forests. First, let's talk about decision trees. Decision trees works by splitting the data into branches based on feature values, leading to a decision at the end of each branch. Each node in the decision tree represents a feature, each branch represents a decision rule, and each leaf node represents an outcome or class label. Now, a random forest takes this a step further. Instead of relying on a single decision tree, which might overfit the data, a random forest builds multiple decision trees and combines their outputs to make a more accurate and reliable prediction. Each decision tree in the random forest is trained on a random sample of the data and uses random subsets of the features. This randomness helps prevent overfitting and makes the model more robust and generalizable to new data. Essentially, it's like consulting a diverse group of experts rather than relying on just one opinion. In this tutorial, we'll walk through building a random forest classifier using the Seatle Weather dataset. First, we need to load our dataset. I've got the Seattle Weather dataset in a CSV file, so let's import it using pandas. So let's import the pandas library, SBD. Then let's create a variable for data frame, then gd.read CSV. And here we have it. Now that we have our data loaded, let's explore it. We'll start by showing the first 5 rows as well as the last 5 rows. As we can see, our data starts from 2012 and goes all the way to 2015. We want to get the weather, if it's like drizzle, rain, fog, or sun. Those are the 4 options. And we will use precipitation, temp max, temp min, and wind to find it. Next, we'll prepare the data for training. We'll select the relevant features and encode the labels. So let's create a features variable. It will be so we want the columns, as we said before, precipitation column, the temp max column, the temp min column, and then finally the wind column. Let's do the same for the labels. So labels will be just one column, the weather column. Next, let's encode the labels. Let's import the label encoder from sklearn. Let's initiate an instance. So label, let's call it label encoder. Will be label encoder. And let's encode our label called labels encoded. Will be our new labels, and it will be our instance dot fit transform, and we'll pass the labels. Run it. Now, why do we need to encode our labels? Well, it's simple, because they are categorical values like rain, fog, sun, drizzle, and we need to transform it to numerical values. And why do we need to transform it to numerical values? Simple, because in many machine learning algorithms, including the random forest that we're going to use, it requires a numerical input. So if we take a look at our newly created labels encoder, if we run it, we can see that it's an array of numbers instead of an array of categorical values. We can see that our drizzle became 0, our rain became 2, that our sun became 4 and our fog became 1. We'll split our data into training and testing data. So we'll import the train test split and we'll create xtrain, xtest, ytrain, ytest will be equal to our train test split, and we'll pass the features. Our newly created labels encoded. The test size will be 20%, 0.2, and let's add a random state of 12. Good. Now let's train our random forest model. We'll start by importing the model from sklearn and creating an instance of the model. So model equals random forest classifier. Classifier because we're going to classify our data. So given the precipitation, temp max, temp min, and wind, we're going to get the weather. We'll add a random state again. State. This random state is completely different from the one above, from the train test split. So let's give it like 21 to be different from the one above. Let's fit our data. So remember, we're training the model, so we'll use our training data, xtrain and ytrain. After training, we'll make predictions and evaluate the model using a classification report. So let's start by making predictions. So ypred will be our model.predict. We'll pass the x test. Next, we'll import our classification report. Create a variable called report. Will be our classification report, where we'll pass the y test, the ypred, and let's set also the target names. That will be our label encoder dot classes with an underscore at the end, and let's finally print our report. So as we can see, our snow precision is 100%. Our rain is also very good. The sun also good, and our fog is not so good, and our drizzle is also not so good. But as we can see, the data isn't the best because we have like 140 rows for rain and only 6 for snow and 8 for drizzle. So our accuracy is 85%, not bad. Finally, let's visualize one of the trees in our random forest. We'll start by importing plot tree and pyplot. So we'll start by creating a figure with a fig size of, let's say, 24 by 12. We'll get the tree. It will be model.estimators. And let's take our first value. We can see what this is. So if we play our model plot estimators, this is each decision tree in our random forest, and we'll be looking just at the first one. As you can see, we have a lot of them. So let's plot it. Let's plot tree, where we'll pass the tree, our first decision tree. Our features names will be our features dot columns, and this needs to be a list, so let's add to list. Our class names will be our label encoder classes, like we did above. And again, this needs to be a list, so to list. We'll add a field equals true. Let's make it rounded also. What else can we do? Can add a font size of font size 512, and let's also add a max depth. So let's only see the first 4. So max depth of 3. We'll only see the first 4 iterations. And finally, let's show it. Dot show. Feature names. Feature names. Sorry about that. So as you can see, we have our first 4, 1, 2, 3, 4 iterations, because we added the max depth. If we hadn't added the max depth, it will be all over the place. We'll start out with our precipitation first, and it will check if it's below or equal. If it's below or equal to 0.15, if it's true, it goes to the right. If it's false, it goes to the left. Then we have our Gini. Our Gini is a measure of impurity used to evaluate the quality of a split in a decision tree. So our goal is to make our Gini as low as possible. That's it for today. Hope you guys learned what random forests are and how important they are. Have a good one.